Hi, my name is Ms. Vu, and today we're going to look at cubic functions, specifically the general form. Dilations and reflections. Similarly to quadratics, where we had x squared, we're now going to have x cubed, and we can dilate and reflect just like we did in quadratics. What does that mean? If we're at 3x squared, a dilation of 3, it means it becomes steeper because it's moving faster. We're multiplying everything by 3. But if we had half x cubed, did I say x squared? I meant x cubed. So if I had half x cubed, everything's moving slower, so it's more shallow. So it's very similar to quadratics. And minus x cubed would mean reflected along the x-axis, which means when it flips over, it's this black line over there. So the red line is just x cubed so that you can compare it. The blue line there is 3x cubed, and the green line there is half x cubed. So half more shallow. So if this is x cubed, then 3x cubed will be steeper, half x cubed would be shallower, and negative x cubed would be reflected. Then we can look at this format. It looks a lot like quadratics, but in quadratics we had hk as the turning point. Today we're going to have hk as also a special point, but it's going to have a different name. It's called the point of inflection. It's a point where it changes direction, and it's also a gradient of 0 at that point, just like the turning point. So for example, if we have that point there to describe it, we will write hk, and we would say the gradient is 0 at that point, and we can write it as p.o.i for point of inflection. Let's now have a look at translations. So this time we're going to have plus 3, which means we're moving to the left by 3. So now our graph is this blue line here. And what about when we have, the point of inflection will be minus 3, 0, because we move left by 3. Very similar to quadratics. What happens if we have x minus 2? It means move to the right. And so now we have the point of inflection as 2, 0. What happens if we have plus 4? Means we're moving up. So the point of inflection is still 0 for the x value, but 4 for the y value. And you can guess that what the last example is, something minus. So minus 2 means we're moving down 2. So our point of inflection is 0 and minus 2. You can see there's very similar patterns to quadratics, except the shape is different right now, and there's a little 3 in the equation. Let's do our first example. Here we can see the point of inflection is 3, 4, and we have a dilation factor of a half. So when you sketch it, sketch that and label that as 3 and 4. So sketch first and then label. It makes it a little bit easier. So to find the y-intercept, it's exactly the same as what we did previously, just let x equal 0. And then when we let x equal 0, we see that 3 squared is 27, but because it's odd, it's minus 27. And then dividing by 2 plus 4 gives us minus 19 over 2. Put that in. And what about the x-intercept? We would work that out by letting y equal 0. So bring the 4 over, we have minus 4 times 2 is minus 8. Then cube root it. What times what times what is negative 8? Negative 2. So now bring the 3 over, we have x equals to 1. So type that in. So you can see that's very similar to quadratics, but now we have a point of inflection, and it's very similar in the way you figure out your x and your y intercepts. That's it from me with cubic graphs. Try and sketch other ones, use your CAS calculator to check your answers as well, and I'll see you next time. Bye!